According to valence bond theory, a covalent bond is formed by the overlapping of two half-filled atomic orbitals. Let us consider the example of beryllium chloride molecule. In beryllium chloride, there are two beryllium chlorine bonds. That means the beryllium atom should contain two half-filled orbitals to form two such bonds. But when we examine the electronic configuration of beryllium atom, there is no such half-filled orbital in the ground state. But when beryllium atom forms bond with the chlorine atom, one of the two s electrons will excite to the 2p orbital, forming two half-filled orbitals. Now these two half-filled orbitals can form bond with the two chlorine atoms, forming beryllium chloride molecule. But there exists another problem. The two half-filled orbitals in beryllium atom, which forms bond with the two chlorine atoms, are not identical. That means the two beryllium chlorine bonds must be different. But this is not what is observed in a real beryllium chloride molecule. Here, the two beryllium chlorine bonds in a real beryllium chloride molecule are identical. How can we explain this phenomenon? This problem was overcome by the concept of hybridization. What is hybridization? The phenomenon of intermixing of atomic orbitals at the time of bonding to form new orbitals which are identical in energy, size and shape is called hybridization. In beryllium chloride molecule, the two half-filled orbitals of beryllium, that is 2s and one of the 2p orbitals, intermix at the time of bonding to form two new orbitals which are identical in size and shape. This type of hybridization is called sp hybridization, and the two new hybrid orbitals formed are called sp hybrid orbitals. These sp hybrid orbitals can overlap with the half-filled p orbitals of two chlorine atoms to form two identical beryllium chlorine bonds. Thus, beryllium chloride is a linear molecule with a bond angle 180 degree.